In my last class, I started with very basic constructions and very basic discussions about permanent magnet moving coil instruments. Okay, and their operating and their operations. Okay, so where we have discussed about the very basic principle and some diagram of that PMMC instrument. So here you can see, in last class I have already discussed that how much range it is used for it, and for versatile applications. Okay, that PMMC very common for means very common. Okay, so here we can see different the structures. Okay, the internal structures of the PMMC instruments. Okay, so from that figure, okay, so here you can see some 3D and 2D figures are given. Okay, so based on that we can understand the basic structure of permanent magnet moving coil instruments. So where in my last class I have discussed that what are the basic principle of operations. Okay, today I am elaborately discussing it. Okay, so here you can see that is that shaft is there. So pivot jewel bearing. Okay, so J1 J2 is there. Okay, the shaft is holding the entire the body. Okay, entire body of the PMMC instrument, where you know there is some metal formers are there. Okay, and C means is the coil, S equals to your shaft. Okay, and B is the width of that format. Okay, so how much the value you have to find out. So here you can see from that cross sectional area the permanent magnet. Okay, so permanent magnet is connected over here. PM means permanent magnet. Okay, and permanent magnet, and internal that it's in cylindrical nature format is there. Okay, so here you can see the diagram. Okay, the diagram is there. Okay, so it is look like a cylinder. Okay, cylindrical structure is there, means core structure. Then you can see the coils are winded up with the cylindrical structures. Okay, means it is holding the cylindrical structure is holding up that coils. Okay, so from this diagram you can easily understand that your that coil. Okay, it's coil C. Okay, coil C is moving inside of that permanent magnet. So here you can see that permanent magnet is totally covered up. Okay, totally covered up the coil. Okay, so permanent magnet, that's why it's a fixed path, and it's a moving coil means it is rotating in nature. Okay, so in my last class I have discussed about the spring, why the springs are there. So springs are providing some counter effect. Okay, if any current is providing through this coil, so here you can see the lines, the diagram means flux diagram of that PMMC instruments. Okay, so where you can see that it's a north and south pole, means permanent magnet is there, two poles of the permanent magnet. So you can see the lines of force are there inside of that core. Okay, so inside of that format. Okay, and it's your moving coil. Okay, moving coil is there. Okay, so it's your moving coil, and that middle hole you can see it is your shaft line. Okay, so you can see that that fluxes are coming inside of that coil, and again it is coming to outside of the coil, and it is coming to S. Okay, S means south pole. Okay, so if the flux lines are passing through, sorry, if you see the flux lines are passing through this coil, means there is a cut of flux. Okay, due to cut of flux, what happen? One circulating current will be there. Okay, inside of the coil, moving coil, one current will be there. Based on that current, yeah, based on the current you can understand there is a chances of a lines of force. Okay, that lines of force is coming due to that moving coil. Okay, so that lines of force are there, and two lines of force means two flux lines are there, they're interacting each other. So you can see that arrow lines are there, so they're interacting each other, and finally you can see that the rotation directions. Okay, the revolving rotation direction you can understand easily. Okay, so that's the basic construction as well as the very basic operations. Okay, so from that figure you can understand what are the important components of that moving coil instrument. So first one is that external shield. Okay, for protection purpose you are using some external shield, that is one, here it is written external shield. Then two is your permanent magnet. So definitely it's your permanent magnet. Okay, inside of the permanent magnet, your pointer, your moving coil will be situated. Okay, then 3 is your moving coil. Here you can see it's your moving coil. Okay, 3 moving coil. Then 4 is moving coil spring. Here you can see the spring. Okay, that is your spring, moving coil spring. And 5 is your pointer, so it's your pointer. Okay, that is pointing out that where it is your pointer pointing out your scale. Okay, so here it is also the pointer. PR means pointer. Here you can also see the pointer. Okay, so it's a 3D diagram. It is given. So external soft coating is there, soft iron yoke is there for the coating purpose. Then you know that permanent magnet is there. Okay, it is a permanent magnet. Then inside of the permanent magnet you are using that coil. Okay, that coil, everything will be holding up by the spindle. Okay, spindle and coil is holding by the format. Okay, so format, and it's a core, iron core is there. Okay, that cylinder is core. Then both sides spring is there. Basically this pivot joining. Okay, pivot jewel joining means bearing, it will be fixing up the terminals. Okay, both the terminal, it is needle shaped terminals. Okay, that is connected, means holding up the system. So the pivot jewel bearing and holding up the entire system in the instrument box. Okay. So it is your pointer, and finally you say like that 6 is the arrangement for the zero balance of the pointer. Okay, so here you know that zero balance pointer, that yesterday in my last class actually I told you that that sometimes coil having, you are giving some reading but giving some minimal voltage or current, but pointer is not deflecting. Okay, so its position is in negative term, almost negative, means just above zero. So what you need to fix up is basically the spring is there due to the edging effect. After some time the spring means efficacy of the spring is going to be reduced due to the aging effect. Okay, that's why what you need to do, you have to control. Okay, you have to control the spring. Here you can see that 2 screws are there. Okay, here you can see different screws are there. So if you move that screw, so that screw is holding purpose here. For the spring there is some also screw. Okay, for changing of the screw means you can change the pointer locations and standardize that. Okay, means your instruments. So what you need to do, if you are a manufacturer, so first design an instrument. Okay, then you have to standardize the instrument with the standard instrument. So and let's check that it is working properly or not. If it is not working properly, so it's difficult. Okay, so again you have to tune up everything for making it and for making your instrument efficient. Okay, so these all are the very important part. These all are the very important part of the PMMC, and they are very basic principle of operations. Okay, so I told you in my last class there are several talks associated with these instruments. Okay, what are the important talks are there? First one is the deflecting torque. Deflecting torque means your pointer is deflecting. Okay, basically that pointer is deflecting due to passing current through your coils. Okay, that may be the main reason for deflecting torque or deflecting force. Okay, TD. And next one is the controlling force. So what is the purpose of the controlling force? So that I told you in my last class also, that C. Okay, sorry, the spring. Spring gives you the counter. Spring may give the counter effect. Okay, counter effect of the deflecting torque. Okay, so that's why in ideal case the deflecting torque equal to controlling torque. Okay, the spring is there. Okay, for providing that value. Finally, the damping force. Okay, so first one is the deflecting force, second one is the controlling force, third one is the damping force. Okay, there is a relation between the torque and the force, so easily you can calculate the torque. Damping torque, controlling torque, sorry, deflecting torque, controlling torque, and the damping torque. What is the purpose of the damping force or damping torque? Basically, basically, if you see the pointer, okay, pointer is vibrating. Okay, you are giving some. If the current is passing through your moving coil, so that due to the reason, means due to the current passing through the coil, so due to that reason, so your pointer will be deflecting. Okay, so the standard spring is there. Okay, that is countering. Okay, that is countering the full deflections. Okay, full deflections. Okay, of your coil. Okay, so that is your controlling force. Okay, so yeah, so controlling force is coming from where? Controlling force is coming from your spring. Okay, so that's why it countering the deflecting force. Okay, when exact deflection is more than your controlling force, so automatically the pointer will be moving. Okay, otherwise what happen? If it is not properly calibrated, okay, then with minimal changes of that magnitude, totally full deflection will be there. Or extreme case also what happen? Changes of some value, it is not deflecting. Two situations may arise, but in your practice, means your actual device, okay, so it will show all those components. Okay, another one is damping force or damping torque. What is the purpose of damping torque? So normally what happened in deflecting torque and counter and controlling torque, both are countering each other. Okay, if they are countering each other, so what happened? So you will get some results. You will, based on the results, you are getting some response. But the problem is that the pointer is oscillating. Okay, the nature of the pointer is oscillating. Means for one place it is oscillating. It's vibrating. Its own place. Okay, that's why it is difficult to getting the exact result. So which one will be the exact one? Okay, so basically it is toggling, okay, with different values. That's why the problem has arisen. Okay, that's why we have to introduce some another term, that is called damping torque or damping force. Okay, what is the purpose of this damping force? Basically the oscillation is there due to, for what? Due to that difference between income and means difference between deflecting torque and the controlling torque. Okay, so in practical cases damping torque is damp out. So how do you damp out that oscillation? Okay, so that's why you need to add some additional thing, like you are using some pistons. Okay, just attached with the point, or some balance load. Okay, that can oscillating or die out that oscillation. Okay, that can die out the oscillations of your system. Okay, that's the basic reason for deflecting damping torque for your instrument. So okay, what are the deflection instruments and the fundamentals? What are the important thing? A deflection instrument used a pointer that moves over a calibrated scale to indicate the measured quantity. So how much quantity is there, you can easily measure. But if it is not properly calibrated, so wrong data will be shown. Okay. So that's why it is important. Three forces are operating in electromechanical mechanism inside of the instrument. So that I have already been that I have discussed already. Okay, if you have any kind of doubt, you can ask me. No problem for it. Okay, so after that, here you can see the operations. Okay, what is your deflecting torque operation? So here you can see the deflecting torque that I am telling you. So in that in the moving coil is situated inside of your permanent magnet. Okay, so that, and you can see that copper coils are there. Okay, so copper coils are rotating. You have sorry, there is a cutter flux. Okay, that flux lines are there. Okay, that is coming from north side to south side, north pole to south pole, and the coils are there. The okay, inside of that inside of this magnet, permanent magnet. Then what happened? The cutter flux will be there, and due to cutter flux, it will pointer will start rotating. Okay, these important points means pivot shaft. Okay, so that it is holding, it also known as that pivot shaft. Okay, and moving coil, here you can see which one is a moving coil. This portion is moving coil. So some core is there to means holding your core. Okay, so here you can see the spring. Okay, here the two springs are there. Okay, one spring in bottom side, another spring will be top side. Okay, it is not mentioned here, but one spring will be there. Okay, so it is called moving coil. Why moving coil? I think you can, all of you can understand why it is known as moving coil, and it is your coil wires. Okay, coil wires. Okay, some of the coil wires are there. So connected to meet the frame. So pivot here, pivot dual bearing you have to use to why? So holding entire device with your meter. Okay, that is the important issue for it. So what is the deflecting force? The deflecting force cause the pointer to move. Okay, deflection force cause means if the current is passing through that deflecting component, so or inductor, okay, or resistance or whatever, if so you are going to be measure of them, so whatever it is passing for that, so there is a movement, okay, due to the current here, so the movement will be there. So the deflecting force causes the pointer to move from its zero position when the current flows. Okay, for any kinds of measurements, okay, resistance measurement, whatever measurement you want up there, so if any meter will be there, so current, due to the changes of the current movement, so it will be rotating, it will rotate. Okay, in PMMC instrument the deflecting force is magnetic. Okay, so deflecting force is magnetic, and swamping resistance, sometimes some resistance is also added series of your moving coil. So what is the purpose of this resistance? So basically what happened, it's a all the time spontaneously it is rotating, then sometimes what happens, due to heating effect. Okay, due to heating effect, your parameters values may be changed, means coil resistance may be changed. Okay, that may cause for changing of your deflecting torque. Okay, so other parameters that may cause for it. So that's why some swamping resistance that is totally unchanged. Okay, more or less unchanged with your changing of the temperature. Okay, so that is connected series with your system. Okay, series with your instruments. Okay. So that is also known as swamping resistance. It is used for multi-range application, or you say like that, if high resistance are there. Okay, so that the cases you are going to be using. Okay, so the pointer is fixed to the coil, so it moves over the scale as the coil rotates. Okay, when the coil are rotating, so pointer is connected to the shaft. Here you can see the pointer is directly connected to the shaft. So if it is rotating, so pointer also rotating. If you fix up the scale, so automatically it can able to find out the unknown value. Okay, so here the basic operations are given. Okay, simple operation in my last class I have already discussed, just like a DC machine type of the DC motor type operations. Okay, and very simple on it. Okay, so why you can see that north pole, south pole, two poles are given, north pole and south pole, and you see that armature, so sorry, you see that PMMC coils are there. Okay, so only one coil is showing. Okay, current is first cutoff flux. Cutoff flux may cause for flowing of the current. Okay, means EMF. Okay, so if the circuit is path is closed, then what happens? That some current will be flow inside of your just security inside of your circuit. Okay, now then what happens, due to current some magnetic field will develop. So here you can see north and south poles are there, both the poles the north and south. So initially the lines of force is like that. Okay, so now what happens, if the current is flowing through this path, then if current is entering, current is leaving. Okay, that's a dot convention is there. If current are entering, okay, so that's why cross conduct concept is given. Okay, just backside of the error when it is entering. Okay, so they're countering. Here you can see the lines of force direction. That portions what happened, that most of the current is countered. Okay, most of the current is countered by this by this moving coil. Okay, moving coil field. Okay, then what happened, you know that this portion will be more place for storing of what, storing of potential energy. Okay, so Again, similar thing also happened for here. So both the end having more source of potential energy, so it is try to means reduce that or convert it to the kinetic energy. So what happened, that may cause for rotation in this direction. So force one, another one is reverse direction. Okay, it is force two. So it is flux line. Okay, and it is conductor flux. So directly coming from conductor flux to flux line to conductor flux, and conductor flux to your means working means directly it is coming. Okay, the deflecting force in the PMMC instrument is provided by the current carrying coil pivoted in the magnetic field. Okay, so how it will be fixing up, that you need to know, means how much pressure you need to give, otherwise huge range it is working but suddenly it may be burned out, so that's why it is required. Okay, I told you that about the controlling force. Okay, now that terminology is familiar to you. Deflecting torque, controlling torque, another one is three torques are there. Na? So deflecting torque, controlling torque, another damping torque. Okay. So three things are there. Okay, so first we are discussing about the controlling torque. So what happened in case of controlling torque? That you know that one the coil is there. Okay, so coil having two terminal. One terminal is directly connected with your pointer and shaft. Okay, it is your moving coil. That is your moving coil, that rectangular shape. So here the shaft is there. Directly it is connected. One terminal of the coil is connected permanently with your moving coil. Okay, moving coil shaft. Another terminal is there. That terminal is connected to the body or whatever structure of that system. Okay, then what happens if controlling torque is more than your deflecting torque? Sorry, yes. So again comparison will be there. If error is positive, so what happens? The pointer will be here. You see the pointer. Okay, the scale is there. It's a positive linear scale. Okay, due to the it is your controlling torque, it is your deflecting torque. Both are countering each other. Okay, which one will be more? So based on that application means which quantity will be more based on it. So you will calculate that how much pointer deviation is there. Okay, so that's why calibration also very important. Otherwise, it will give you wrong results. Okay. So that spring constant is there. Based on the spring constant, you can calculate the value. So controlling force is there. Okay, so first it will start with the controlling force. So the controlling force in the PMMC instrument is provided by the spiral spring. So what type of spring you are using? Spiral spring you are using. The spring retain the coils and the pointer at their zero position when no current is flowing. So how it will be written? That spring constant, you have to include some spring, means dedicated for this purpose. So if you tune that one, so automatically you can see that no current is flowing, or zero position there will be no current. Okay, so that you need to that's the way we need to manufacture or tune, like. The coil and the pointer stop rotating when the controlling force becomes equal to the deflecting torque. Okay, so up to which portion, that I am telling, the reference block is there. Okay, when actual value is just similar to your means reference value, then what happens? Then zero error will be developed. That zero error will be fed to the system. So that means zero error means you were not able to do that experiments. Okay, so that's why it is important. The coil and the pointer stop rotating when the controlling force becomes the equal to deflecting torque. So at that time it should be rotating. Oh, and stop the rotations. Okay, the spring material. Okay, the spring material. Okay, must be the non-magnetic. Okay, so spring material should be non-magnetic. Okay, to avoid any magnetic field influence on the controlling force. Okay, so that's why permanent magnet you are telling, but natural magnet you are not going to use over there. Okay, you may use for electromagnet. Okay, that may be another option. Okay, so that's why it is mentioned that the spring material must be non-magnetic to avoid the magnetic field of influence on the controlling force. Otherwise, that force may be give some influence for it. Means more parameter deviations, yeah, maybe there. Okay, so like that. So the controlling, here you can see the diagram, the controlling force from the springs balances the deflecting force. Okay, the spring are also used to make the electrical connections to the coil. Okay, so they must to low resistance or piezo bond, phosphor bond in the phosphor bond is the material usually employed. Okay, so that you are using for that purpose. Okay, damping for force that I am telling you. So if both the controlling torque and your deflecting torque, if both are the same, so what happens, the pointer will be oscillating, okay, at that position. Okay, it is your actual position, okay, but it is oscillating by changing that value. Okay, so that may cause for unnecessary error. Okay, so which portion is correct, okay, that you need to select and you have to use it. Okay, so that it is given, okay, some response is given, like with the after the PI instrument, okay, how it will be look like that. Okay, so that is given here, the diagram is given here. So what are the important points of the damping factor? Okay, first we need to know the important points. Okay, the damping force is required to minimize. Okay, so you have to minimize the damping force or damp out. Okay, so that is your first consideration, the oscillation to the pointer and the coil before setting down that final position. So first you have to remove, okay, remove the energy storage. Okay, or you say like that, here we are using battery or fuel cell, whatever sources are there, you have to remove first. Okay, the oscillations of the pointer and the coil, okay, before settling down their final positions. Okay, so if you all the thing you have been removed from there, so only that controller will be there. So now you need to check, is there any other oscillation or not. If other things are there, so we have to take the necessary steps. So but from the figure you can understand that we are asking for the critically damped. Okay, not so much fast and not so much sluggish. Okay, so we have to design it for all we have to design it at the means and keep it in your mind. Okay, the damping force must present only when the coil is in motions, thus it must be generated by the rotations of the coil. Okay, these all are the important features. Okay, so next features is that in PMS instrument the damping force is normally provided by eddy currents. Okay, so definitely eddy currents having also countering effect for it, so it can also help. It can also help. Okay, for manufacturing a device. Okay, that's why it is important. The eddy current is induced. Eddy current induced in the coil set up a magnetic field that operates the coil motion. So definitely simple like DC motor principle. Okay, so here you can see some scaling is there. Now the pointer, initially some overshoot is there. Okay, so the overshoot star has referred in mentioned. Okay, so how much overshoot that you need to check. Okay, overshoot, undershoot. Okay, then rise time, peak time. Okay, and normally these we are checking for it. Rise time, speed time, and speed time, and settling time means how fast your disturbance will be reached by that controller. So that also prove the efficacy of your controller. Okay, so means here the spring controller. Then another thing is that if there is a less rise time, means system will be very fast. Okay, see how much fast your system is. So system behaves means if system is fast, so automatically all the reading will be fetch or catch. See, very simple. Okay, then eddy current losses are there for the coil set or magnetic flux. So if there is any magnetic related means flux related or means whatever things are there, so eddy current also be capable for it to doing this test. So here I have already discussed that for the damping force, what you need to do and how it will work, that is already discussed. The determine force of a PMMC instrument is provided by eddy currents including in the maximum coil former as moved through the magnetic field. So that's the basic reason for the damping force. How you are damp down there. Okay, so then some pivot wear dwelling pivot wear pivot dual bearings are there. Okay, so what are the different types of that there is a spring here, you know that metal yoke is there outside of your body. So then what happened, that pivot bear pivot dual bearing is connected to the shaft both at the end. Okay, so it is known as jewelry bearing. Okay, so two things are there, so it is known as jewelry bearing. Okay, here another one is that dual bearing. Okay, and it is a pivot, so both the case it is known as pivot and coil you need to give. Okay, so here the details direction of pivot dual bearing is given. So here the spring spring supported is there. Okay, support of the spring is there. So here diode and I think here two methods normally we are using. The method of the supporting of the moving system of the deflection instrument. Okay, what are the important points? Number one is dual bearing suspension. Okay, so that bearing also connected but it is in suspended mode. Okay, next one is the cone shaped next one is the cone shaped cart dual bearing. Okay, next then low possible frictions, some level bearing some dual bearing has been supported to absorb such shock. So important point is that it can absorb the shock. Okay, and easy accessible and anybody can use it. Okay, so nothing very complicated one, so you can be use it. Okay, but the main problem is that not like this instrument, so there is some sound problem may be there as the motor generator is running on. Okay, so that you need to keep in your mind. Okay, so torn bend modeling means, so this is another modeling structure. Okay, where two moving coils are there. So here you can see that moving coils are there inside of that meter. Okay, so current is flowing through that meter and pointer is deflecting the value. The match together can then join bearing. Okay, so they are in together but they are not able to join it now. Okay, so two bearings are there and connected to the spring. Spring is look like a different manner. Okay, because of the spring the metal revolves. Okay, because of the spring the metal revolves have like rubber under the mention. Okay, thus the ribbon also exert the contouring force as they twist it. Okay, so how much value, so you can easily find out it. The metal bobbins can be used for the electrical connections to the moving coil. Okay, uh, much more sensitive than the dual bearing type for this. Less frictions. Okay, that's having less friction, that's why it is important. Friction energy is extremely rough, not easily shared. Some additional portion also is there that is not shared. Okay, I think all of you will to understand. Okay, so PMMC construction is there. I will start it in my next class. So what are the PMMC constructions? That I have already been discussed, some very basic equations and numerical problems. Okay, based on the PMMC that we will discuss in my last class. So if you have any doubt, you can ask me. Okay, so if you have any doubt, you can ask me.